So thanks everyone, and see how much time I've got. I've got 20 minutes, which is going to be a bit of a race. But thanks for the opportunity speaking today. I'm going to talk a little about getting your data ready for scalable AI. I'm not going to talk so much about the AI use cases themselves. I've already heard this morning a couple of use cases, and some of those are very, very prevalent, and we certainly are implementing similar use cases across the European continent. So my name's David Wainwright. I'm a principal consultant data and AI. I work for PRODYNA. We're a pan-European system integrator. We create bespoke software for enterprise customers. So I'm based in Germany. I've got 25 years of experience in IT. I'm a graduate of Imperial College, so just up the road here, and I'm a natural scientist. I don't usually say that much about myself, but I'm speaking here to an audience that's primarily customer experience oriented. And from my profile, I wouldn't normally be a person that speaks about customer experience, but something happened last year that kind of changed that and kind of changed the demands that are being placed on data, and that's what this talk is about. So until last year, this was my world. So I'll be working with data platforms, we'd do data engineering, which is the manipulation of data, and then we'd take data, create models, and we'd do big data analytics with that data. So up until November 22. So what happened in November 22? Well, probably most of you know that was the general availability of ChatGPT. So what has that changed for data? So let's go from right to left. So we have AI-infused applications that what customers want now. So, and they sit on different types of services. So the large language models, such as the GPT models from OpenAI. And what's the big change here? Most of you probably know that the programming language of the GPT models is natural language, English, German, or whatever language you want to use. And that makes it makes data available for new use cases that weren't really there before. Because we can speak to these models, such as GPT, but there are many, many others, in a natural language, people in the business department can start using data in a much more approachable and easy-to-use manner than was previously available. So we have a customer experience on top of AI-infused applications. We have different types of AI services. We have the large language models. Of course, we have the machine learning models. And these things need data. So without data, we can't really use these AI services properly. So I think it's fair to say in the coming years, the customers are going to demand new use cases. They're going to demand new functionality from you, from your web pages, from your organizations, that you will need to implement using AI, because there won't be any other reasonable way to implement these functionalities. And to be able to do that, you're going to need data. So that's really the essence here. How do we power these things? How do we get our data to the AI? So before I go any further, I want to clean up one little misconception, and that is there's two personas here. There's the consumer world, and I think probably everyone uses ChatGPT or the other AI services in this way. For example, a couple of questions here. Can you generate a picture of something? Or you want to ask a question. Who was the US president in 1961? Or you're going to visit someone, you want to know what the best locations to visit are. Or you want to generate some text, or your children probably want to do their homework, so write a poem about something. And the chatbot goes away and says, okay, and he completes that task. But here we're the consumer, so we want something from the bot. We're kind of expecting the bot to know everything or to be able to do everything by themselves. We're not really giving the bot any information or any of our own information. So this is the consumer world. I think we all use these bots as a consumer. But we work in an enterprise world, right? And we are providing the bot to our customers. And normally, the normal use case is, for example, in a customer service organization, we want to, for example, generate some documents or automatically answer customer mails. So what do we need to do? We need to go away into our back-end systems. We need to search for relevant documents. We then give these documents or parts of these documents to the AI and tell the AI, please answer the customer email. So quite often we have a system speaking to a bot, right? So we need to provide information to the bot, and we're just using the generative capability, the natural language capabilities of these bots to create an answer using the information that I provided in a natural language of our choice. So without data, we can't really use these bots in an enterprise situation for creating a positive business value. So we need to provide data. So this is what this talk is about. And we work with enterprise customers, and there are two main problems that we see at our customers. And these problems are quite often so large that projects can't get started. The number one problem, I guess everyone probably knows this, is that data is in silos. So most customers have different systems, a CRM system, an ERP system, supply chain management, so product engineering, might be a legal department, or shadow IT systems. And all of these systems are completely independent of each other. And if I want to extract data out of these systems, well, in many cases I can't because I'm not allowed to. And then the second problem is all of these systems use different formats. The data is in completely different forms, so they're difficult to combine. And the third problem is the data is completely without context. Right? So if I want to recreate the context by searching one of these systems, that's a fairly computational, complex task. It's going to take time. I can't do this on the fly, or a bot can't do that on the fly. We need to get data into different forms so we can use data in other forms to give to the bots to be able to answer questions. So let's take an example. So just pretend we're a construction company. And this construction company does large building projects. We have an example here, the Spree Arena Berlin that I made up, a multi-sport arena, and so we have different personas that want to get information from this bot. For example, the engineer might want to get the technical documentation about the drainage of the basement. Or the project manager, give me the last estimate to complete numbers. Or the marketing, can you show me some product renderings? Or we then have customer personas. Can you give me the latest version of the floor plan? It's not the version, not a floor plan, but the latest version. Or when can I expect the electrical installation to be complete? These are not simple questions. They're not simple questions that can be answered, or here's the document. Yeah, we're expecting here the bot to extract information and then to make calculations in other systems and then retrieve that information and then generate a reasonable answer. So we need a lot of data, and we need that data in context of each other. And we certainly have customers that are going right down this track. So these are practical examples. So what happens if we take siloed data and try and power a bot on top of it? Well, the first thing is we probably only find a few little pieces of information because that data is stuck in the silos. And as I said, these points aren't joined together. So we want the latest version of a document, not a version of some document. The rest of the data is stuck somewhere. We don't even have access to it. What we really need is this type of data in this type of form, where the individual pieces of information are joined together. Imagine you find £1 million on your bank account. That's a data point, £1 million. But the more interesting thing is, where did they come from and why are they on your bank account, right? That's the context we need if we want to power intelligent bots, if we want to have a positive customer experience. We need to get these pieces of information together. These are the windows on the ground floor for this building, or this is the project plan for this building and not any type of building. What really helps is bringing your information into a structured document. What you see on the right-hand side there is a structured document that we produce, or in this example, for a project. It's one document that's structured, that contains all of the information that belongs to this project in context to each other. So we're redesigning pieces of information. We're taking information from different back-end systems and putting them together and creating pieces of information, that a bot can understand and use as the basis for answering proper questions. So that's what we kind of need. Most organizations don't generally have information in this format, but if they do, we kind of get to the second problem. who is actually responsible for joining these dots and putting the information together? That's generally the data team. And the data team generally has a big data platform. This is big white block here. It's generally a monolithic, centralized, relatively difficult to use piece of software that manages data. So what do? They ingest data from all different parts of the organization. They then clean, enrich, and transform this data, get rid of the rubbish and bring it into new forms, and then serve new data sets to the consumers. That consumer might be an application, the consumer might be another department within the organization, or might be the web page. Essentially, we take data, bring it into a new form, and then serve it out again. This is the big data platform. Let's go in a little bit more detail and look at how this process can be decomposed. So on this ingest parts, the first bit is we ingest the data, right? We then clean it up and then serve it. But the people that do that, the people that build the ingest pipelines, are different from the data scientists that are actually looking into data and thinking about, okay, what is the business value in that data, and how can I understand that data, and how can I create new data sets? These are different roles and different tasks. And the people that create APIs to serve that data out. So we have a couple of problems here. We have the extreme high pressure on the data team, because it's just one monolithic team of people. The number of data sources is continually increasing. We're in the world of data and AI. Yeah? We have a second problem, that the innovation agenda of customers is increasing, so the demand to produce more and more new data sets to power new use cases is increasing by the week. And we have a further problem, that the way this architectural quantum is broken into stages, silos the knowledge within this process. So this is compounded by the fact that when we have a change, when someone comes to the data team and says, okay, next week we have a new use case and we need new data sets, these lie horizontal to the way this team is set up. So if a single change means we have to build new ingestion pipelines, we have to process that data, we need to create new APIs to be able to serve that data out. So a single change involves work for all of these different people. So the people that are already under stress, they're under, in many cases, almost close to meltdown, because they're being stressed to produce more and more data. Every single little change means that all of these people are affected and they have to communicate with each other. And it gets even worse because they are sandwiched between the cross-functional teams that are producing data and on the left, and the cross-functional teams on the right that are consuming the data, right? They've spent the last couple of years becoming agile. They have cross-functional teams. They work in agile teams, scrum teams, or squads. But somehow the data teams, we have people working with data, have been forgotten in these agile processes. So you can see the situation here. We want more and more data from these people, and there's absolutely no scalability. The data is in silos, and the knowledge about how to work with the data is in a silo. So enough of the problems. How do we go about solving these? Well, one possibility is the idea of distributed data mesh. And this is a philosophy. This is a change management process. So essentially, we have 4 pillars here. We have the data itself. Then we have to start thinking about breaking up the data into different business domains. We have to think about a self-service platform so that more people can use data. And we need to think about data as a product for each of these individual domain-specific teams. So let's put the business in the middle. If you remember the last slide with the big white block, it has data platform in the middle. So let's put the business in the middle and break up our business into different domains. On the left, we have a couple of domains that, or parts of the business, departments, however your business is broken up, that are mainly involved in producing data. And we give the data ownership that was originally by the data team. So originally the data team has the data ownership and the responsibility for everything. We're going to now democratize this data ownership and give ownership for parts of this data to the different domains. And on the right-hand side, we have other business domains that are responsible or primarily involved in consuming and reusing the data. So the architectural quantum is now the domain. The next question is obviously, okay, we've broken up the data team. We don't have a data team anymore. We don't have a central data platform anymore. So who's going to do all of the work? Well, the simple answer to that is we move the work from the central data team to the domain-specific teams. And each domain-specific team is responsible for their business. And their business is now producing data, right? So now we're going to have the responsibility for producing, cleaning, and serving the data. We're going to move it out into the domain. So we're going to take out the bottleneck of this central data team. That's what we see here in our cross-functional team. We've now augmented the team that had some business experts, they usually had some software experts, project manager. We're going to move the data engineer, or maybe even an AI engineer, into the cross-functional team. And the team is now responsible for their business and producing data as a business. And that brings us on to the next point. So we now have our cross-functional teams. They've got to think about data as a product because a lot of businesses these days are moving away from thinking just about tangible products, but producing data as a product. And obviously there's a whole list of attributes that data has to have. It has to be discoverable. We want to share data or data sets within the organization so other parts of the organization can reuse this data. It needs to be trustworthy. That means other parts of the organization need to be able to rely on the data, that it's accurate and complete. It has to be self-subscribing so other people can understand what that data is. So this is this concept of data as a product. We have to move that into the cross-functional teams. We've spent the last couple of years making the IT agile. We've mixed the business department with the IT. We can now do agile IT projects. But we've forgot about the data up until now. And the rise of generative AI is putting so much pressure on organizations that we need to act now quickly and move the data and the ability to manipulate and create data into the cross-functional teams that we've forgotten previously. So we've now got rid of our central data team. We've got rid of the monolithic data platform. So what's missing now? So we put all of the skill into the cross-functional teams. What we now need is a self-service data platform. So up until now, these data platforms were horribly difficult to use, right? You really had to be trained, had to be certified. You needed many, many years of experience to use these data platforms. There was certainly nothing trivial and certainly nothing that was close to the business. So what we're seeing now is the rise of self-service data platforms, also called data fabric. And these are easy-to-use platforms that are provided by a central infrastructure team. They also have a set of attributes, such as scalability. We need to be able to version data. We need a proper data governance. We need a data lineage solution that we can see how the individual and singular data attributes have moved through the company. So where does this data originally come from? How have we modified the data? In what form is the data now? So these data fabric products are now providing a fairly simple SaaS solution data platform for everyone, specifically designed for these cross-functional teams. Without wanting to push one product too hard, we do a lot within Microsoft Azure. Microsoft Fabric is one of these self-serve platforms. And what you can see here is we have a series of different functionalities. We have Data Factory, it's for the ingestment pipelines. We have a whole set of tools for data engineering, data science, data warehousing, and real-time data. We have Power BI for data visualization, and we have Data Activator, which is a kind of business rules for data. When what's pursued, when something happens in your data, then you can automatically do something, send a mail, sound an alarm, call the police, whatever. And all of this functionality sits on top of a common data store. So not everyone has to share their data with everyone. No one's going to do that. But when they're working with a common data store, they can create data sets within a common data store that makes sharing easy. And now we have our cross-functional teams. These products are much, much easier to use. They're AI augmented. In many, many cases, there are parts of these applications or use cases which can be simply low code. So people that So originally you needed to do a degree, and in data engineering to manipulate data it's got a lot easier, yeah? With different personas within the single application that cater to the data engineer, the data scientist, the data analyst, people creating dashboarding solutions. It makes it much easier. And this whole thing sits on the whole cloud infrastructure. So we have single sign-on. We have our user and roles and rights management. We have the multiple compute engines right underneath the data, and all of the other services that we need to properly secure the data. So this whole concept of data fabric is the self-service platform that sits underneath the cross-functional teams and takes away this bottleneck in the data platform teams. And that will certainly, or this is the concept, to make data scalable within the organization. So, and just to finish up, right, with the same slide that I started with, and we can work from left to right. If we want the customer experience, then we need the data. And to produce data in the quality and the quantity that is currently being required and demanded by larger organizations, then we need to do something on the left-hand side. Data mesh, that's breaking up this monolithic data team, that we get democracy within the data, that we give back ownership for the data into the part of the organization that should actually be responsible for it. We're starting to think about producing data or data sets as a product. Yeah? There's a value within the organization. And then we have data fabric, which makes doing these jobs much easier. So that is essentially what I wanted to say. Not too much about AI. We've already heard about the use cases. But without the data, then we can't power this AI. And without the AI, we can't create the customer experience that customers are going to demand in the next couple of years. So with that, I hope I was on time. 20 minutes. And I hope that was kind of a sort of short insight into what is behind the AI. Everyone's talking about the AI, but without the data, it's going to be difficult. Thank you very much.